Hey guys, I'm back. So I know I don't usually do science news, but um, this is just so exciting that I have to. So this is the Higgs results have just come from Fermilab, and CERN is posting their Higgs results at 1 a.m. Eastern Standard Time, 2 Central, 3 Mountain, 4 a.m. On the 4th of July. So if you are that interested to wake up early for the Higgs, if you live in the U.S. at least, I will certainly wake up that early, but we will see. CERN will post their Higgs results then. So in the meantime, what I'm going to do is I'm going to talk about the Fermilab Higgs results. I'm just sort of going to explain what this video is going to be about. I'm going to explain the Fermilab Higgs results just a bit here, head over to the computer so you don't have to witness this bad green screen effect as much, and then come back to give my predictions for the LHC Higgs results that will be given, and predictions for the Higgs in general. So let's start out. Behind me we have the Fermilab Higgs results with this standard graph here. And so what the results say is that the description of the results says that they have a 2.5 sigma in the mass range, and in total they have a 2.9 sigma. So this is relatively high for something that was designed so long ago. It was never expected to be this good at detecting the Higgs. The thing is that Tevatron has a slightly easier time detecting the Higgs because a proton-antiproton collider, which is what Tevatron is better suited, and its detectors are better suited for detecting the B-anti-B pairing. And the Higgs will decay to a B-anti-B a lot of times. That's its main decay mode. Whereas something like the LHC, just a proton-proton collider, is better suited for seeing a twin photon event. And while the B-anti-B is a more messy signal, it's more difficult to pinpoint the signal. It's a lot. It happens a lot more. So for Tevatron to get a 3 sigma or 2.9 effectively at such a messy signal is pretty incredible. But the LHC is doing a twin photon, and the Higgs rarely ever decays to a twin photon. It's very rare for that to happen. So the LHC is having a harder time pinpointing the Higgs for that reason, because LHC, they're searching, CMS and Atlas mainly are searching for twin photon events, whereas CDF and D0 we'd be searching for twin photons. But anyways, basically they have basically confirmed the exclusions that the LHC has made earlier. So we are down into the 114 to 135 GeV mass range, and we're almost done. So I'm going to head over to the computer to explain this little 3 sigma, or 2.9 I should say, sigma result that we're getting for the B-anti-B pairs at Tevatron. So we'll head over to the computer and explain those results. Okay, so now I'm explaining the Higgs results from Fermilab. So as you can see here, we have a basically these guys are confirming the exclusions that the LHC has already made. As you can see, 2.5 sigma, as I said, in the mass range, and 2.9 sigma for the B-anti-B channel decay mode, which is the easiest way the Higgs can decay. But for all the decay modes, W's and twin photons, we have 2.5 sigma. So obviously 2.5 sigma is lower than 2.9 sigma because twin photons and W's don't have as much as B-anti-B's. So that's why the signal is stronger for B-anti-B's than it is for everything. So if we scroll down here to this graph right here, which is the useful one, the one that means the most. If we see here, the mass range is basically between here and here. Okay, well actually more like here and here. So here. So basically we can see that it's way above what's this. It basically is 2 sigma. This yellow here is 2 sigma. This is 1 sigma. This is 10 sigma up here, and this is 1 sigma. This line. I keep dragging that all around. Okay, so we can see that right here there's a little spike. It's sort of flat here, and it spikes here on 130 GeV. And we have this spike here on 120 GeV. So this is why I predict it's at the lower end of the mass range, is because this little spike here. And as you can see, Atlas is done a little bit of an exclusion here, so it's leaving this lower end of the mass range, which is where I believe the Higgs to be, and it's leaving this open. So if we look, you can see that there's like spikes like these all over at 120 GeV, if you look on all the graphs, and they way exceed the 95% confidence level. They're a bit below the 95% confidence level is what I meant to say. And a 95% confidence level is the same as 5 sigma. So that's why that's basically Fermilab Higgs results is spikes at 120 and confirm. So basically the Higgs results, as you can see, like from this graph here, we have the lower limits, upper limits, 2 sigma results here. Again, yellow is 2 sigma, or standard deviation as they call it, same thing. You can see the lower limit of the mass range is about right here. The upper limit is about right here. So as you can see, we are getting these spikes at 120 GeV, which is what causes me to believe that the mass is at a lower range. But basically, we're getting, in the mass range, we're getting an excess signal for, this is for all the decay modes, twin photon W, NW minus, and BB minus. So we're getting a little bit of a spike at 120, but we're getting a 2.5 sigma on average for all decay channels in the whole available mass range, which is between here and here. So yeah, so it looks like the Higgs is likely, because this is our mass range, this is where it's allowed, and we're getting tantalizing hints. This is the graph that you really want to pay attention to here. This is right where I believe the Higgs to be, at least, and you can see we have a little bit of space there. It's where I think the Higgs is. I think this is going to be gone right here. We're going to eliminate that. But that's the Higgs results, really. You can see we have a few sigma here. This is where our 2.9 sigma is coming from, right at the top of the mass range. Is right here. This is about the top of the mass range. The CMS exclusion thing right here. Not excluded enough. It's widely considered the mass range is 114 to 135 GeV. So we have a little spike here at the end of the mass range, and here at the beginning of the mass range. So also this Atlas exclusion isn't enough to widely be considered not part of the mass range. So yeah, this is where I believe the Higgs to be around here, but as you can see, Fermilab through all the decay modes is saying it's confirming the Higgs is in that mass range, and it's giving us a spike in that mass range that's saying, well, the Higgs could be in the mass range, but also it probably is. So, yeah. Okay, so now that I've explained the Tevatron Higgs results, we're seeing that little bump at about 120 GeV roughly, we've confirmed the mass range is definitely 114 to 135 GeV. Let me give my predictions and reasons for those predictions on the LHC Higgs results that is coming up 1 a.m. Eastern Standard Time, U.S., so on the CERN webcast. So let me predict. I predict right as of now, because of the Fermilab results, I am 100% certain there is a Higgs boson. There is no doubt in my mind that Higgs doesn't exist. The standard model is completely true, okay? So let me just say that. That may be biasing these results slightly, but I do have reasons to back them up. So first thing is I predict that definitely there will be a signal. The signal will be between 4 and 5 sigma, but not 5 sigma, so at most 4.9 sigma, coming from both Atlas and CMS at a mass on the lower side, so like 115 to 120 GeV. And so why do I predict this? One, I predict you need 5 sigma to make a discovery. Okay, so I'm predicting that they won't make a discovery, but they're going to be like right there, so close. So the reason I predict this is because the LHC is searching for a more rare decay mode, the twin photon, so they're going to get less of a signal. And just because they've produced about as much data as last year, slightly more, and last year we got a 3 sigma candidate. So I think that since the LHC has increased to a 8 TeV center of mass energy, that extra jump will result in a bit more sigma result than last year's data. Plus, we have last year's data to back us up. But I don't think they're going to make a discovery because I just don't think they have enough data. Also, the fact that raising the beam energy to 4 TeV per beam means they have a bit more messy signal to work with. So there's more background events. So it's slightly harder to separate the Higgs in that regard. So I think we're going to have a between 4 and 5 sigma jump at the lower end of the mass range. I just explained why I think we're between 4 and 5 sigma. But we're going to have it at the lower end of the mass range because that's the hardest place to find the Higgs. And it's taken us so long, and we've been looking all this time, that I think it's got to be in the hardest place to look. Also, the Tevatron results are hinting at a 120 GeV mass, which is closer to the lower side. We've had results from the LHC and the LEP at a lower end of the mass spectrum. So that's my reason for thinking that it's going to be at the lower end of the mass spectrum, is that it's harder. It's the hardest place to find it, and we've had clues that we have results that 3-ish sigma results, 2-3 sigma results, that it's going to be at the lower end of the mass spectrum. So that's why I think it's going to be that. So those are my predictions for the LHC results coming out on the 4th of July. I don't think they're going to discover it, I said, but I have no doubt in my mind that it exists. But again, I could be proved wrong. I'm not a particle physicist, so I don't work for CERN or Fermilab, so you never know. We could only have 2 days of waiting before the Higgs is discovered, or we could have. My prediction is that the Higgs will be discovered by the winter at the winter conferences. The results will be revealed, and it'll have about 6, 7, 8 sigma results. Then, because they'll have the rest of the energy of the rest of the run, 2012 run. So definitely the Higgs exists. They'll definitely find it by the winter conferences. We may have an early discovery on the 4th of July. So exciting. But what does the discovery of the Higgs actually mean? For those of you wondering, why are we so excited to find the Higgs? Well, we're so excited to find the Higgs because we've been looking for so long and we haven't seen it. So that's enough to get us excited. But also, it's the last piece missing in the standard model. There may be a few excited states, like the LHC Atlas, and CMS just discovered the Xi sub B or whatever you call it. I'm not sure that's the correct pronunciation or even the correct particle. But an excited state of, I think, a B anti-B bonammonium meson. It could be a baryon. I'm not sure. Anyway, it was some excited state of some hadron that they discovered. So there could be a few of those that are like predicted and they haven't been found yet, but I don't think so. I think the Higgs is the last piece in the standard model. So that means that once we've completed the standard model, this is the most complete theory particle physics has ever had. And since I think the Higgs exists, I think it's withstood everything we can throw at it now. So I believe the standard model will hold. That means that once we know the standard model, basically confirming what the standard model predicted has been the goal of particle physics ever since it started, ever since we had the standard model. And now we're going to have to look for other things like supersymmetry and other theories. Look for dark matter, look for WIMPs, more neutrino physics, stuff that's not in the standard model, and that'll make us have more innovative and new theories that could predict other stuff and really give us way exciting results. Because can you imagine how exciting it'd be to detect a SUSY particle? A lot more exciting to detect SUSY, dark matter, stuff like that than it would be to detect Higgs. Not that detecting Higgs is not exciting. So that's what it means. It means that we can move from the standard model to all new physics, extra dimension, SUSY particles, WIMPs, dark matter particles, all that stuff. So that's going to be in our range now once we discover the Higgs. And also, this has nothing to do with it, but whenever they discover that Higgs, that day I'm going to make a T-shirt to sort of commemorate the day. So I guess whenever that happens, I will make a video posting the results of the summer conferences. Whether they discover the Higgs or not, I will explain the results just like I just did for the Tevatron results. So, and if they discover the Higgs, you'll see my shirt. If not, you'll have to wait for the winter conferences, which I predict will discover the Higgs then. You see my Higgs shirt. So, thanks for watching.